Okay, so we're going to do part 3 of exponents and radicals. So we'll just start with some examples, remind you what we've been working on. So if we have the cube root of 64, well, 64 can be broken down into factors. So this is 32 times 2. 32 is 2 times 16. 16 is, if we want 4 times 4. And so what we have, if you look at the bottom of each of these, we've got a 2, 2, 2, 2, 2, and 2. So 64 is 1, 2, 3, 4, 5, 6 2's. 2 to the power 6. So you should be familiar with the powers of 2. That will help you later when we do logs. So what I mean by that is 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. And if you're familiar with these, it will help you. And this is really as far as you need to go, but you could go further to 128 and so on, but you should be familiar with those. So if you see like a 16, you know that that's a power of 2, that you can write it as a power. Okay, so back over here, 2 to the 6. Now a 1/3 power, or root, is a 1/3 power. You multiply the exponents, so 6 over 1 times 1 over 3. When you multiply fractions, multiply the top and multiply the bottom. 6 divided by 3 is 2, so this is 2 squared, which is 4. Okay, in the same way, 4th root of 16. Well, 16, if we look over here, is 2 to the 4. And here, when these match, the 4th power and the 4, they actually just sort of cancel out, and the answer here is 2. If we look at this the long way, that's a 1/4 power. So that's 4 over 1 times 1 over 4, which is 4 over 4, which is 2 to the 1, and 2 to the 1 is just 1, 2, which is 2. Okay, a third example, the 5th root of negative 32. So a negative can be under a odd root, because you can have negative signs. Now 32 is 2 to the 5th. So be careful with this. So this is negative 2 to the 5th, or negative 2 all to the 5th power, because negative odd power is a negative. So 2 to the negative, and these would cancel, so we would just get negative 2. Remember, that's the same as the 5th power times 1 over 5, which is minus 2 to the 1, which is minus 2. Now sometimes you just want to put a radical into its simplest form, and it doesn't necessarily work out nice like those last ones. So 8 is 4 times 2, and then once you have these multiplied, you can say this is the square root of 4 times the square root of 2, which is 2 root 2. The root 2 doesn't work, but the square root of 4 is 2. So that does work. So putting x's in and doing something similar to this would look like, say we had 32 x to the squared y to the 4. So first of all, you can think of this, since these are all multiplied, you can break it down. We're going to use this a lot in the course, actually, right up until the last chapter. You're still using things like this. Now, square root of 32, it doesn't have a square root, but 32 is 16 times 2, and 16 we do know the square root of. Square root of x to the 2, square root is a half power, and This is also a square root, so that's also a half power. This is 16 times root 2. These cancel, because it's 2 over 2. Let's just write it down. So that's a 1. And this is 4 over 2, which is 2. Square root of 16 is 4. Square root of 2 we don't know. This is just x to the 1. You don't need to write the 1. And this is y squared. So that would be your answer. Now sometimes you'll see the square root of x squared written as the absolute value of x, and this is more correct to see it this way. I'm just not worrying about that in this course right now. This is more correct. It's just saying that the answer has to be positive because you can't have a negative under a square root. And this is that type of example. So this would not work. There'd be no solution. But if we had the 4th root of 81, well, 81 is 9 times 9, which is 3 times 3. So 81 is 3 to the 4th power, 1, 2, 3, 4, and they would cancel, and that would be 3. This one is not negative 3, because negative 3 times negative 3 times negative 3 times negative 3. Remember, negative signs, if we have an even amount of them, is actually positive 81, not negative 81. Okay, so this does not have an answer. So we would just say no solution if it doesn't work. So if we had the square root of 75, that would be the square root of 75 is 25 times 3. The square root of 25 we know is 5, and the square root of 3 doesn't work out, so we just leave it that way. Now let's put a negative again, but this time under a cube root, so this one is okay. We've got a fraction, so we would say the cube root of negative 16 over the cube root of 125. If these work out, then great. Now 16 I don't believe is a cube root, because 16 is 4 times 4, which is 2, 2, 2, and 2. So there's actually 4 2's. We want only 3 for it to work out nice, but there's 4. So we could write this as 2 cubed times 2 to the 1, right? Or you could write it as 8 times 2. Now we do know the cube root of 8 is 2, because 2 cubed. So we can do that. Now what about 125? Let's write it over here. 125 is 25 times 5. This is 5 times 5, so there is 3 5s. So 125 is 5 cubed, and that's good because we want a cube root. So the negative sign is fine because you can have a negative, so the answer is going to be negative. We can actually take that out and not worry about it. Now we said that this was 8 times 2. 16 is 8 times 2. And this is 5 cubed. The cube root of 8 we know. The cube root of 2 doesn't work. And the cube root of 5 does work. So cube root of 8 is 2. This one stays. And this is 5. So that would be your answer, and that's how you would write it. Sometimes people ask me about the negative sign. This was on top. It doesn't actually have to be on top. It could be in front. You could think of it in front of the fraction, on top of the fraction, or even on bottom is still correct. It's still the same thing, although we don't usually see a negative on the bottom like this. You would just put it in front or on top. Okay, so let's look at some negative exponents and fractions. So negative exponents mean that we have 2 to the negative 1 is the same as 1 over 2 to the 1, and this would be 1 over 4 to the positive a half. You don't need to write over 1, but 4 to the half is the square root of 4, which is 2, so we have 1/2 plus 1/2, which is 1. And let's just write another one right here. So if I had 2 times 3 to the negative 2 minus 5 to the negative 1. So this would be 2 times 1 over 3 squared minus 1 over 5 to the 1. So because the negative exponent moves down to the bottom. Now this is actually one number. You would multiply that. So this is 2 over 3 squared. That 2 is like a 2 over 1. You multiply the tops and you multiply the bottoms. You don't need to write over 1. This is 2 over 9 minus 1 over 5, and now you would need a common denominator. So common denominator of 9 and 5 would be 45. Multiply this one by 5 and this one by 9. So we would have 10 over 45 plus, minus 9 over 45, which would be 10 minus 9 over 45, or 1 over 45. And let's just do an example of a fraction. Okay, so do you see that these fractions sort of have a denominator that looks the same? The bottom looks sort of the same. What's different is that the denominator actually has the opposite sign. You'll see this a lot. So basically what I'm saying is x minus 1 is, if we put a minus, it's not going to be equal. If we put a minus in front of x minus 1, we get minus x plus 1, which is the same as 1 minus x. So this is like a positive, and the negative is here. So they're the opposite sign of each other. So if you're doing the common denominator, they're actually very similar. They're just different by a minus sign. So what you would actually do to get the common denominator is multiply one of them so that they're the same by just a negative 1. So what that would look like now is 3 over x minus 1 plus minus 4 times minus 1, over minus 1 plus x. So you would multiply that in, and this is now the same. Let's write it the other way. These have the same denominator. So we have 3 plus a minus 4 over x minus 1, which is 3 minus 4 over x minus 1, or negative 1. Okay, now if you didn't notice that they were opposite signs, you could do it out a longer way, and you would get the same answer, but it would involve simplifying. So let's just do that and show you, because sometimes you won't notice that they're just opposite signs, and you won't choose the best denominator. You'll choose a common denominator, but maybe not the best. So let's look at that. So the same question, but done a different way. So you didn't notice that these are the same. So what you say, okay, well I need a common denominator. I'm going to multiply them by the denominator of the other. All right. Now, whenever I do this and I have something that's factored on the bottom, I am not going to multiply that out. I'm just going to leave it like this, okay? So we do have a common denominator now, so we can write it as one fraction. And what I'm saying here is leave this alone. Okay, don't multiply it out. So here we've got 3 times 1 minus x plus 4 times x minus 1. We're going to expand these. So 3 times 1 is 3 minus 3x plus 4 times x plus 4 times minus 1. And again, I'm just leaving the bottom alone. Factored form, when things are multiplied only, they're always simpler. Here it wasn't factored because of this plus sign in between, and that's why I'm choosing to multiply out the top so that I can potentially write it in factored form. The bottom is already simplified. So here we've got 3 minus 4 minus 3x plus 4x. I'm just rearranging them just so you can see how to group the like terms. So 3 minus 4 negative 1, and minus 3x plus 4x. So minus 3, take away 3 from a positive 4x, is plus x. So which term is this the same as? There's a negative 1 and a positive x. It's the same as this one. If we just switched around so the positive was first, we'd see these are the same. And we could cancel them out. If you cancel everything on the top, there's a 1 as a placeholder. Now look at this answer and the answer we have up here. They look slightly different, but remember that they are the same. So why are they the same? Let's just go to the next page. I'm going to write down this answer and just show you that they are the same answer. It just looks different, and that's fine. Sometimes you have an answer that looks different than another answer, but it is actually the same thing. So let's just write those two answers down. Remember I said that these were similar except for the sign was different. So whenever you have off fraction, you can always multiply by anything on the top and bottom, and that doesn't change it because it's like multiplying by 1. Minus 1 times minus 1 is 1. And here, you would multiply that out. Minus x minus 1 times minus 1 is plus 1. And it's equal. The other way you could do it is multiply this one by minus 1 over minus 1, and you would get what we started with the first one. So they are equal. Okay, so a couple more fraction examples. So minus 2/3 minus 1 over 6. Now, again, these minus signs, this could be minus in front of 2/3. So if you look at like a type, how it's typed on a computer, it might look like this. But that is saying the same thing as minus 2/3 plus a minus 1 over 6. Those are the same still. This is the same as, you wouldn't write it this way. You wouldn't normally see it that way, but it's still the same thing. Now, what is it different then? You have to be careful. If you see minus 2/3, some people think that that minus applies to everything, but it's saying that the fraction is negative. You can only have one negative sign for it to be negative. So this is not the same as minus 2 over minus 3. Be very careful. Okay, that isn't the same. Minus 2 over minus 3 is actually plus 2/3, not minus 2/3. Okay, now let's just get the answer here. So first you would need a common denominator, which would be over 6, so multiply that by 2. And the second fraction is already over 6. So minus 4 over 6 minus 1 over 6, minus 4 minus 1 all over 6, which is minus 5 over 6. And that would be your answer. Okay, and then some other questions that are useful and will help you with your homework in the fraction section is an example like this. That's an S. S's aren't very good to use in questions. They look like 5s, but nevertheless, let's do it. What would the common denominator be? The common denominator would be R times S times T. So here, we need to multiply the first one by S and T, the second one by R and T, and the third one by R and S. Let's put an equal sign here. So we have ST over RST, RT, because 1 times RT, over, write them in the same order, so you can see that they're the common denominator. I'm just writing them all in the same order. Remember, 3 things multiplied. R times S times T is the same as S times R times T. They can be in any order. D times R times S, and so on. Write them in any order, and they're all the same. So now we've got the same common denominator, so write it as one fraction. Now just look, my T's have a little curl on the end just to make sure they don't look like a plus sign. The S, make sure it doesn't look like a 5 so that you don't get confused. Now if you look at the top of this, the numerator, there's actually nothing we can do. They aren't all the same variables, so you can't add them together. Meaning if you had like 5x plus 6x plus 2x, those are all the same variables, so you could add them together. 5x's and another 6 is 11, and then 2 more is 13x. But here we don't have the same variable. They don't all have a t, and actually they have 2 variables, so that would be the answer. You would just stop right there. Now if these were numbers instead and you had 3 fractions added, then you would do the same thing. Your common denominator would be 2 times 3 times 5, which is 6 times 5 is 30. Okay, but you would sort of look at this the same way. This has a 2, so you need the 3 and the 5. Or you could write times 15. The 1/3 needs the 2 and the 5. And the 5 needs the 2 and the 3. So this would be 15 over 30. 2 times 5 is 10 over 30. And this would be 6 over 30. Now they all have the same denominator, 30, but now we can add the tops because they are just numbers. 15 and 10 is 25. 25 and 6 is 31. And you would just leave your answer like this. Don't use mixed numbers. And if you forget how to use mixed numbers anyway, you're okay. A mixed number, this would say 30 goes into 31 once, and there would be 1 over 30 left. Don't use mixed numbers like this. Leave your answer as an improper fraction, and that's better in calculus. You're never going to use a mixed number in calculus. Okay, one last example for this lecture. X squared y to the 4th to the negative 1/2, going back to exponents and radicals. Okay, here it is. So this first bracket has a negative power. So you're going to write this as 1 over x squared y to the 4th all to the 1/2. This one is a positive, so it will stay on top. And you can think of it as lined up with the top of this. This is like over 1. These are two fractions, so this would be x, y squared all cubed over x squared y to the 4th all to the half, like this. Now, what you do, these are x times y, so that 3 applies to both. So you would say x cubed y to the squared times 3. You multiply the exponents. This would be x squared times 1/2, that's the 1/2 power, and y to the 4 times 1/2. That would be, y to the 6. 1/2 times 2 is 2 over 2, which is just 1. 4 over 2. 4 over 2 is 2. So we have x cubed y to the 6 over xy squared. And now look at these and see that there's 3 x's on top and 1 on the bottom. So you think of them as canceling. If you have, let's write in a different color, x, 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 and then 6 y's. 4, 5, 6. That's what's on top. On the bottom we have just 1 x and 2 y's. So if you look at these as being matched, so x over x, those cancel. So we have just x squared left on top. 3 minus 1 of them. And here is 6 minus 2 of them is 4. If you cancel out 2 of these, you're left with 4. And the bigger, or the more x's were on top, or the bigger power is on top, and the bigger power, so these are on top. If they had been reversed, then, and there would have been some left on the bottom, you would have still had a fraction. Okay, so that's it for today. We're actually done that section now, so you can go and try the homework for that section.